Good morning. The hearing board of the South Coast Air Quality Management District is in session. Today is Tuesday, April 24, 2018. The time is approximately 9:05 a.m. and we are meeting in the hearing board room in Diamond Bar. We have one change to the afternoon calendar today, and that is the pre-hearing teleconference that was scheduled today for Tesoro Refining and Marketing has been rescheduled to May 24th, 2018. The parties are still in discussions over the contested conditions, and the contested conditions are in place. And so that pre-hearing teleconference has been rescheduled. We have one matter on calendar today, and that is the City of Los Angeles Hyperion Treatment Plant, case number 1212-37 for a short variance. And who is representing the City of Los Angeles today?
Adina Hopenstand, Deputy City Attorney, representing City of Los Angeles LA Sanitation.
Thank you. And who is representing the Executive Officer this morning?
Mary Reichert on behalf of the Executive Officer.
Thank you. And anyone who wishes to testify or may testify today, including any members of the public, please rise to be sworn in. Please raise your right hand. Do you promise to tell the truth, the whole truth, and nothing but the truth, so help you God? Thank you. Okay, before we get started, Ms. Hopenstand, I believe you came into the clerk's office and maybe you had some additional exhibits. Did you wish to introduce anything or have any preliminary matters before your opening?
I have presented to the clerk here today their exhibits. They're not pre-marked, but that way they're for easier distribution once they're introduced.
Okay, so we'll wait till they're introduced. Okay, so then let's start with your opening.
Thank you, members of the board. We're here today on a short variance petition or petition for a short variance regarding the Hyperion wastewater treatment plant, which we will refer to as Hyperion or the plant interchangeably today. You will hear testimony this morning from both Sherry Simons and Michael Wise about necessary repairs that need to be made to recently discovered damaged equipment in the desulfurization facility at the plant. To make the repairs, LA Sanitation will need to shut down the desulfurization facility, which will result in violations of the permit and rules regarding the sulfur content of gas when the desulfurization facility is offline. Ms. Simons will provide background information as to what role the desulfurization facility plays in the wastewater treatment process, and specifically its role in reducing the sulfur content of the waste gas, or digester gas, also called dye gas, that is a byproduct of digestion of sewage sludge performed at Hyperion. Ms. Simons will explain the impact on emissions during the variance if granted, and LA Sanitation's mitigation efforts to reduce overall flaring of the digester gas, and also mitigate the sulfur content in the dye gas itself while the desulfurization facility is offline. Mr. Wise will provide more details about the repairs and the intended staffing to try to minimize the duration of time that the desulfurization facility is offline. And he will also address the safety reasons for why this repair work can only be performed when the desulfurization facility is shut down. The city submits that following its presentation of evidence this morning, that the Rule 515 findings to support grant of the variance will be supported under the circumstances here. And with that, we're ready to present evidence when the board is ready.
Thank you. Ms. Reichert, your opening.
Good morning. Subject to compliance with the proposed conditions and the testimony presented here today, the district is not opposed to the granting this variance, and I will present the proposed conditions now.
Thank you. Why don't we take a moment before we begin testimony to mark, pass out, and review the proposed conditions. We will mark the proposed short variance conditions as Exhibit A for the district. And we're going to go off the record for a few minutes to review the proposed conditions before we begin. We're off the record. We're back on the record. Ms. Hopenstand, you may present your first witness, please.
I'd like to introduce Ms. Sherry Simons. Ms. Simons, please state and spell your full name for the record.
My first name is Sherry. Last name is Simons. It's spelled S-H-E-R-I. Last name is S-Y-M-O-N-S.
Ms. Simons, what is your position at the city and your job duties?
I'm an environmental engineer at the Hyperion Water Reclamation Plant Process Control Group, Process Control Engineering Group. And one of my responsibilities in the group is to manage the plant's Title V permit, which is being responsible for the monitoring, record keeping, and reporting requirements of the Title V.
And do you understand that you are under oath this morning?
Yes.
In the course of your testimony, I will be focusing on the desulfurization facility and the repairs that are at the heart of the petition that we're here for today. But first, I'd like to ask some questions about the wastewater treatment facility generally. So my understanding is that once sewage enters the plant, the liquid and solid components of the sewage are separated. Is that right?
Yes.
And could you please describe briefly what happens to, or what's the first step in the process of treatment of the sewage sludge?
The solids that are separate.
Yes, Senator.
There are some diagrams in this petition about systems operation.
Do you have your microphone on?
What?
If you can speak into the microphone.
They have diagrams in the system. And as I looked at paragraph 4, item number 4, it describes specifically how the system operates, purpose of it, and how it's done. And I think.
Do you want to follow along with that?
But yeah, maybe you ought to post it. So this is without public notice. So as you're talking, they will get a pretty good understanding what's going on here.
Just so you know, just so we're all aware and on the record, there was public notice of this hearing, and also these diagrams were filed as part of the petition, so the public should have access to them, but I think it's a good idea if you
Just walk us through this.
if you wish to do it.
Okay, go ahead.
Let me make sure that we have the right diagram. Could you please clarify which picture you're referring to?
Paragraph 4 discusses the operation of this system. So and you're going to be talking about the system's operation and what it does and so on. So you know which diagram that is. So.
I actually think that the witness is looking at the wrong diagram. It is a diagram we plan to introduce today. So I just want to make sure that we are
Then this is like the right diagram,
Yes,
okay?
exactly. So you are looking at the petition, is that correct?
Yes.
And
I think it would be best to use whichever diagram the witness believes is the more appropriate diagram to help walk the hearing board and the public through the testimony.
Okay, excellent. We will do that. So one is a new addition, exactly. The clerk has located it. It's entitled Hyperion Water Reclamation Plant Digester Gas Handling Schematic, April 2018. We will have that distributed to the members of the board and have testimony on that document, as well as attachment 1 to the petition is another schematic.
Okay, so for the record, there is a schematic that is attached to the petition, which is entitled Hyperion Water Reclamation Plant Desulfurization Process Schematic, April 2018. We will not mark that as that is part of the petition. And we've received a second schematic, which is entitled Hyperion Water Reclamation Plant Digester Gas Handling Schematic, dated also April 2018, and that will be marked Exhibit number 1 for petitioner. And when you get to that portion of your testimony, I think the best thing to do would be to come here to, I think the clerk could probably help you to display that. And then if you could turn on the microphone there and use that microphone for the record, that would be most helpful. The clerk will do that. So it's there, and you just have to center it or raise it. Perfect. Thank you, Ms. Simons and
sure.
Ms. Openstam, and you may continue.
Ms. Simons, I was asking you about what happens with the sewage sludge. Is this schematic, could you please illustrate what happens with the sewage sludge in the wastewater treatment process?
Yes, the sewage sludge, it enters the anaerobic digesters for anaerobic treatment, and what that does inside the anaerobic digester is microorganisms break down the biodegradable fraction of the sludge. And what that does is it brings down the mass of solids, and also it brings down the pathogen concentration. One of the products of digestion is digester gas, and that's collected at the top of the dome of the digester. And from there, the digester gas is collected in the LP gas holder after that. And that digester gas, it's a mix of methane and carbon dioxide, roughly a 65-35 blend. And there are also some trace organics and also sulfur in that gas. And from there, it's typically then compressed and goes through the desulfurization facility. It goes through the desulfurization facility, and that's where the H2S, if it's above 40, it's brought below 40. And after it's been desulfured, there are three options. The gas can be combusted in the plant's cogeneration facility to produce electricity and steam. If that's not available, it can be, a portion of it can be processed in the plant's boiler to produce steam only. And if none of those options are available, the gas can be flared.
Now, there's another schematic that is introduced, attachment 1. Could you briefly explain what that has to do with the treatment process?
And here's a block diagram of the digester gas facility. And what happens in that facility, right there. The digester gas facility, the desulfurization process is a low-cap process, and it is a wet scrubber. So from the bottom, digas enters an absorber, and then a iron-rich, a ferric solution meets it, and the ferric solution reacts with the sulfide, that's the hydrogen sulfide. And what gets produced is ferrous sulfide, and so that the ferrous sulfide is removed from the digester gas, and that the iron can be reoxidized. When it's reoxidized to be reused again, the sulfur is released, and the sulfur can be removed from the system as solid sulfur. So that's the continuous sulfur removal of the digester gas.
Now, Ms. Simons, you mentioned that there's a 65-35 blend in the digas or digester gas. What did you mean by that?
Digas, its constituents, it's approximately 65% methane, 35% carbon dioxide, and then there are also other trace organics and H2S.
And the desulfurization you referred to is to reach 40. Is that 40 parts per million?
40 parts per million of H2S, to be below 40. Like, for example, currently it happens to be operating at about 10 parts right now.
And H2S is hydrogen sulfide?
Hydrogen sulfide.
And why is there a hydrogen sulfide 40 parts per million requirement?
Hydrogen sulfide, when it's combusted, becomes a sulfur oxide, or SOx, and that's a precursor to acid rain, or a component of acid rain. And so there are emission limits on hydrogen sulfide combustion.
And the requirement that there be a cap of 40 parts per million of hydrogen sulfide content in the digester gas, is that reflected in any permit that the city has?
Yes, it's reflected in its operating permit. It's in facility-wide permit condition number 4.
And that was included as part of this petition?
That was included as part of the petition, yes.
And you also referenced in your description of the treatment process and in the different schematics that you've been testifying to, use of low-cat as a wet scrubber. What is low-cat?
Low-cat's just a method for removing sulfur from sulfur gas. And it is a proprietary product, so when I'm saying it's an iron solution, I actually don't have all the constituents of the solution. As I said, that's part's proprietary, but it is the main ingredient is the ferric ion or iron.
And this solution that you've described with the iron treatment, that's what happens within the desulfurization facility?
Within the scrubber itself, yes.
And that's in order to remove the sulfur in order to meet permit requirements?
It removes the liquid solution. It's removing that sulfur from the gas phase. It's taking it out of the digester gas.
And if you could go back to Exhibit 1. So after the gas enters the low-pressure gas handling facility, what happens next to the treated gas?
I'm sorry, one more time? I apologize.
After the gas is, as a byproduct of digestion, enters the low-pressure gas handling facility, is that what you're pointing to now?
Yeah, the low-pressure gas holder.
What
yes.
does that do?
That's just a holding tank. It handles production and pressure variations.
And next to the low-pressure gas handling is a circle. What is that?
That's a compressor.
And what is the compressor doing?
The compressor is needed, the gas needs to be compressed. It needs to be at a higher operating pressure in order to pass through the desulfurization process and be conveyed to these three options.
And the typical handling of digester gas, assuming desulfurization facility is operating, is from the compressor to the desulfurization facility?
Yes, it would be compressed going through the desulfurization facility. Yes.
And then what happens to the digester gas after it's treated with this low-cat solution you briefly described and whatever else is happening within the desulfurization facility to remove the sulfur? Where does it go next?
First priority is the cogeneration facility to produce electricity and steam.
And I see 3 arrows shooting off of the desulfurization facility, and you mentioned first priority. Are these alternative options of combustion?
If cogen is not available, the plant can produce steam in its steam boiler.
And otherwise?
Otherwise, if these 2 options are not available, the gas can be flared.
And just for purposes of another visual aid, I have a document that I would like to mark. There are 2 photographs of the digesters. I'd like to mark it as Exhibit 2 and have them distributed. That's the first, and we'll have them both as the same exhibit. And Ms. Simons, you're the only one without the exhibit, so let me give those to you.
Oh, that's okay. I've seen these things pretty much every day for the last.
It might be good along the lines of what the senator was asking for, to, since you're up there, to project them for the public. And let's mark them. We've got 2 photographs. One is headed digester gas pipelines, and we're going to mark that as exhibit number 2 for petitioner, and the other is entitled digesters, and we're going to mark that as exhibit number 3.
Just to give you an overview, Hyperion has 20 egg-shaped digesters, and they hold their capacity is approximately 2.5 million cubic feet. And these digesters produce about 7 million cubic feet per day of digester gas. So the liquid level, it's actually quite high in the vessel, and the orange lines, those are gas collection lines. So the liquid level would be approximately here. Digas is formed and released at the top, and probably right here, you can see one right here. It's collected off the top of the egg and collects in a main header that's then conveyed to the low-pressure gas holder and the compressors and desulfurization facility.
And if you could turn your attention to Exhibit 3, can you see the desulfurization facility relative to the location of the digesters?
Yeah, here's a zoom out of one of our batteries. Here are the digesters again, and the desulfurization facility is here on the right.
Ms. Simons, why is a variance being requested?
In this case, the plant is requesting to do preventative maintenance work at the desulfurization facility. And the work that's going to be required on the equipment, some of the equipment is on the combined line for gas, and also combined line for the liquid solution for the desulfurization process. And they're on the main lines, and for safety, those need to be removed from service and purged before maintenance can go in and safely replace or install equipment.
And Mr. Wise will be testifying to greater detail as to the repairs, but can you generally give us the idea of the nature of the equipment that's being repaired?
Would you like me to use, I'm sorry, would you like me to use the other attachment, or?
Certainly. So we have attachment 2 to the petition, as well as attachment 3.
Let's see. This one should be listed as attachment 2. This is a detail of the gas handling at the desulfurization facility. And here it's coming in to the left. It's referred, the dye gas is referred to as a sour dye gas here. It still has, it has H2S in it, or a high H2S level in it. And it goes through a knockout drum to remove any moisture. And then can separate into 2 trains. We have an A and a B train. And these are the wet scrubbers where the low-cat solution is coming in contact with the digester gas to remove the hydrogen sulfide. Some of the work that's going to be done in this one here, the knockout drum, this is a pressure vessel, and it has a pressure safety valve, and it's on a 3-year cycle to be replaced. And so that's one of the items that we're going to be doing, is replacing this pressure safety valve. In addition, there's a location right here. It's listed as a FIT 503. That's the indication for a flow meter for a flow element. We have a flow element right there. It's an orifice plate, and we're going to be changing out that orifice plate. As you can see, these are on the main lines before we have our separation into a train A and a train B. And then, in addition, on the liquid side, this is on attachment 3. This is a detail of the liquid process for low-cat solution. And up at the top, these are the same absorber towers as on the other sheet. But in this case, the solution that's being supplied, it's first in the recirculation, or it comes into the recirculation tank. And these pumps here, the recirculation pumps, are what distributes the flow to the 2 absorbers. The work that we're doing here is on these 2 pumps. They have check valves on them. These check valves are going to be replaced. If these check valves fail, what can happen? This operates at high pressure. If one of these check valves has a leak in it, the other pump can push flow back into the out-of-service pump or the standby pump, and it can start rotating backwards. And if that operator were to start that pump while the impeller was rotating backward, it could do major equipment damage to that equipment. So that's one of the items that we're going to be replacing, is a leaking check valve. And then up here, the low-cat solution flow into the absorbers is controlled by flow control valves. And around the flow control valves, so this is a detail I added that it wasn't here originally in the schematic, is that the flow control valves have a bypass loop. So if the flow control valve fails, the valve can be isolated and removed from service. And the flow control is necessary for process control. An item that has come up is that they've noted, operations has noted that some of the bypass valves are not sealing. And so what they'd like to do also is to replace these bypass valves. And these are isolation, these 3 valves are isolation valves around the flow control valve. And this This diagram or this setup here is typical for all four. And again, these are on main lines going into the facility. And Mike can address why the system needs to be out of service in order to safely replace this equipment.
And you're asking for the facility be offline during the replacement period?
Yes,
And why is that generally?
primarily for safety.
And what is the scope of the variance in terms of duration or time?
We're asking for 4 days. Part of this is a large system, these gas lines that are feeding this system, they're 12-inch and we're looking at about 200 feet. To safely isolate the system, operations needs to purge the system, and they're going to do a nitrogen purge on that because the concern is that methane, it's a fuel, it's combustible. So it needs to be safe, or the atmosphere needs to be safe before maintenance can do some of their work that's there.
Why,
What was the rest of the question?
could you please break down in general what's happening over that 4-day period? You mentioned the purge.
I'm sorry. Yeah, the first part of it is a purge of the system, and then maintenance will do the repair work. Estimate is actually 1 day, but we're asking for a factor of safety in case there are, like, there's, at the end of the plumbing work, they're going to do something like a leak checks, and this is if something happens, like if there's a leak, that they have that extra time in order to make that repair.
Is there time involved in re-energizing the facility?
And then there's another approximately 1 day to restart the system.
If 4 days proves unnecessary, the safety factor that's built in of a day that you mentioned is not needed, what's the intent of sanitation?
The intent is to start it up as soon as possible.
And why make the repairs now? What is there any timing consideration?
For this time period that we've asked, dig up, our cogeneration facility has a scheduled annual outage coming up, and there'll be a time period where they will be unable to accept any digester gas. So at that point, the plant would be potentially would be flaring its digester gas, or if it's possible, it could also put it into a boiler. If we're not able to put it into a boiler, we'd actually have to purchase natural gas in order to produce steam for the plant.
And so the intent is to have this shutdown for the repairs coincide with a planned shutdown?
Of the cogeneration facility, to take it, because that's going to require flaring, and then this would just be happening at the same time.
So will this reduce overall flaring necessary or overall combustion of the gas?
Yes, we're trying to overlap the work so that in the future we don't have to do flaring in order to make these repairs that I just outlined.
And the cogeneration facility you mentioned that produces steam and steam and electricity from the digester gas, that's a scheduled shutdown of that facility. Why?
It's for preventative maintenance.
And that's
they have an
permitted?
annual, pardon?
And that's permitted?
That's permitted, yes, they have an annual turnaround.
We've spoken about why LA Sanitation is trying to time the shutdown of this desulfurization facility concurrent with this annual preventative maintenance of the cogeneration facility. But why do the repairs now of the desulfurization facility? What's the reason the repairs are needed?
Well, the facility is still functional. What this is these are preventive to improve, well, let's see, for example, what's on here? For example, the check valves. Like I said, the pumps are still functioning, but to have those check valves in place, it could prevent future equipment damage. If, for example, and as I'd mentioned, an operator were to start a pump while it was rotating backward. So that'd be to prevent equipment damage. The flow control valves, the isolation valves, the flow control valves are fine, but they are critical to the process. If they go down, that's going to be a much longer breakdown that's going to need to take place if we cannot isolate those valves.
Is there something that alerted LA Sanitation to the need to do these repairs and valve replacement, flow meter replacement and the like, or flow meter elements?
Pretty much these were discovered by operations during routine operation. And the other, this is for the liquid. Let me just switch back to number 2.
This is attachment 2 to the petition?
So this is the gas, this is the gas schematic. The pressure safety valve here, that's on a 3-year schedule. That's on a preventative maintenance schedule. That's why that one's being done. And the orifice plate, the orifice meter has regular calibrations, but we noticed that the plate, we'd like to have that flow element there. It's not reading. We'd like to have an accurate flow meter that's right there. So that's as needed.
And approximately when did sanitation notice that the flow meter needed some attention?
I honestly, it was about 2 to 3 months ago.
And what have you been doing, or sanitation been doing, in the 2 to 3 months period prior to this variance hearing today?
As I mentioned, this equipment is all still functional. We're trying to take advantage of, to be coincident with the shutdown at the cogeneration facility. But from discovery, materials had to be ordered and installed. Or I'm sorry, they had to be ordered and delivered.
And there's been some mention of an orifice plate. Is that, for example, equipment that you can buy off the shelf?
No, that's engineered.
And has it been engineered and fabricated in this 2 to 3 month period we're talking about?
Yes, it's been engineered, fabricated, and received.
And what is the purpose of the flow meter?
The flow meter is to get an accurate gas flow going into the absorbers, and it'd be used for controlling flow into the 2 absorbers. So it'd be used for, oops, sorry, it'll be used for process control, and also it can be used as a backup for calculating emissions if we have a problem with the downstream flow meter.
What is an orifice plate?
It's a type of flow meter.
I have an exhibit that I'd like distributed. It's entitled Hyperion Water Reclamation Plant Orifice Type Flow Meter, and it has a few images on it. I believe I will.
We have received an exhibit entitled Hyperion Water Reclamation Plant Orifice Type Flow Meter, and we will mark that as Exhibit 4.
Ms. Simons, when you're ready, if you could please describe what Exhibit 4 is illustrating.
Yeah, this just is an overview of an orifice plate. This is the top left hand. This is the theory of how it works. In the gas line, there's a constriction, and the pressure differential between the upstream and the downstream is proportional to the gas flow. And to the right is an exploded diagram of an orifice meter, and basically this portion here is the orifice plate. This is what we're going to be installing in Hyperion's gas line. And this is an actual picture of the orifice plate that we're going to be installing. And this is a close-up of the location for the installation site. So it'll be going in between these 2 flanges.
And the orifice plate and flow meter on the main line of the facility?
Yes, they're on the main line of the facility. And I just wanted to note, and this may come up in Mike's testimony, there is a corrosion on one of our pressure taps that needs to be addressed during the outage.
How often is the desulfurization facility subject to preventative maintenance?
Preventative maintenance is continuous. It's quite a large facility. It's continuous based on maintenance or manufacturer's recommendations for all the equipment that's involved.
And are such items as the flow meters, orifice plates included as part of the preventative maintenance and operational inspections?
For example, the calibration would be a routine preventative maintenance item, but the replacement of an orifice plate, that would be an as needed.
If the variance is granted, will there be excess emissions of hydrogen sulfide in excess of the 40 parts per million during the time of the facility shutdown?
The hydrogen sulfide concentration would be over 40, and after the gas is combusted, there would be excess, or there'd be SOx emissions, yes.
And what is the total estimate of the excess emissions, if you can recall?
If I remember right, the final emissions were going to be about 71 pounds per day of SOx emissions is what we were estimating.
And the 71 pounds includes mitigation efforts?
Yes, it does.
And what mitigation?
There are a few items. There are some other alternative ways to address hydrogen sulfide. One of them is to add ferrous chloride to the sludge before it enters the digester. Like I said, the LOCAT system is much more reliable and more cost-effective, but we can add ferrous chloride to bring that number down. Or we're doing that to bring that number down to that 71 pounds per day.
Why is ferrous chloride not regularly added to sludge in the attempts to reduce hydrogen sulfide?
It's much more expensive, and the results are not consistent.
Does it have an impact on the equipment?
Yeah, in high enough concentrations, it actually can start precipitating out and could cause a plug in the line, or restrict and eventually plug a line.
Is there anything else being done to minimize emissions here? Or the emissions impact, rather?
Probably the biggest one is that this is going to be coincident with a scheduled shutdown. That's one of them. Another one is that our crews are going to be working continuously on this. As soon as the system operations purges the system, the crafts are going to be in there to start their work.
What are you going to do to monitor emissions during the facility shutdown?
To monitor emissions, the combustion equipment that we have on site, they have flow meters available, and then we can also measure the H2S in the gas, or we can still measure that. So we'll be able to quantify the emissions from the concentration in the flow.
And you have had an opportunity to review the conditions of the district Exhibit A, including some of the monitoring and reporting requirements. Is LA Sanitation in agreement with those?
Yes.
And have any other mitigation options become doable other than, since the filing of the petition, and other than the timing, the coincident timing, and the addition of ferrous chloride?
Yeah, excuse me, yes. Since the application was submitted, they did an evaluation on the compressors, and some of the compressors are going to be available during the shutdown. So when the compressors are not available, I don't know if you want me to put that, I'll just put that first exhibit back up.
And this is Exhibit 1.
This is the compressor here. When it's not available, the only option is for the gas to be flared. When a compressor is available, there's a bypass around the desulfurization system, and the gas can then be combusted in. The cogeneration facility is going to be down, but we'll have an option to run the dye gas through our process boiler to produce steam.
And does the process boiler have a particular number or designation?
Boiler number 2.
At this time, I'd like to introduce 2 other exhibits. One is entitled Facility Permit to Operate, LA City Sanitation Bureau, Permit to Construct/Operate, permit number G42943. And when the clerk is ready, I have another exhibit.
Ms. Openstein, was this permit to operate different from what was attached to the petition?
Yes, it's relating to the boiler that's under discussion.
Okay.
And the next exhibit is a table, and it's entitled Hyperion Water Reclamation Plant Mitigation Measure to Reduce Flaring. The witness will be testifying as to both momentarily.
Let's begin with the facility permit to operate, facility ID number 800214, permit to construct, operate. We're going to mark that as Exhibit 5. And then we also received an exhibit entitled Hyperion Water Reclamation Plant Mitigation Measure to Reduce Flaring, and we will mark that as Exhibit number 6.
Ms. Simons, in the Exhibit 1, in that flow chart, there was a boiler number 2 you identified. Is Exhibit 5 the permit associated with that boiler?
Yes, it is.
And can the boiler accept digester gas with a sulfur content greater than 40 parts per million?
No, not 40 parts per minute, not greater than 40 parts per million.
And
It would need to be included as part of this variance.
And that 40 parts per million requirement, is that in one of the attachments to the petition?
Yes, it is. It's a district rule, and it's included in the plant's permit.
And can you describe generally what that plant permit is or the condition number?
It's in the facility-wide conditions, condition number 4, and it should have been the first permit attached to the application.
And we've also distributed Exhibit 6. It appears to be a table with the title Hyperion Water Reclamation Plant Mitigation Measure to Reduce Flaring. Could you please describe what this document represents and why you're familiar with it?
Yeah, in the first scenario, this was how we understood that the facility was going to be operating when DGUP was when the cogeneration facility was out of service and no compressors were available. We're assuming that we'd have to run 100% of the dye gas through the plant's flares and have to purchase natural gas to run the process boiler to produce steam. Now, reevaluation, the compressors will be available. And so we're looking at scenario number 2, where no natural gas needs to be purchased. All of the dye gas, the boiler can accept approximately 30% of the dye gas produced, and then the balance, 70%, would be flared.
Can all of the digester gas be combusted in the boiler as opposed to requiring some flaring?
No, the boiler can only handle about 2 million cubic feet per day, and the plant produces about 7.
And that's because of the large volume that we saw with those digester photographs earlier?
Yes.
And are there any environmental benefits and specifically emissions, air contaminant-related benefits for proceeding with this mitigation option and utilizing boiler number 2 in addition to flaring?
Now, with these 2 scenarios, the amount of SOx, the mass of SOx produced is the same. We assume that the H2S that is present in the digester gas is going to be converted 100% to SOx, and that'll happen either in the flare or in the boiler. What I wanted to bring this up as an option is that there are other emissions that will be reduced. The boiler's much more efficient, is much cleaner than a flare. So the plant would be flaring less if a portion of the dye gas could be put through the boiler.
Without the variance, will the city be in violation of any rule or regulation or order of the district if the desulfurization facility is shut down for these repairs?
Yes, it will be.
And do you know what those are?
The first rule is Rule 431.1, which puts a threshold on the H2S content of gaseous fuel.
And anything else?
Yes, there are 2 others. I apologize. I do not remember the numbers in front. I think one of them is 3002, and I want to say 203. 203 requires a facility to have an operating permit and to comply with its permit. So it'd be in violation of that because our permit does state that we have to comply with Rule 431.1. And then the other one, 3002, Hyperion's a Title V facility.
And
It needs to be in compliance with its permits.
Pardon me. And did the petition for the short variance reflect the rules and that you just described that would be in violation were the city to proceed with a shutdown with no variance?
They were included in the application.
And what would be the impact on the facility if these repairs weren't made now or soon thereafter?
Potentially, like I said, most of these are preventive items, and it's better to do it and you'll hear this in other testimony, it's better to proceed with this in a planned manner than wait for something major to break down. Like I said, everyone will be staged, the equipment and the people will be staged, ready to go to make these replacements. In an unscheduled breakdown, this could happen, for example, on a Saturday night. Assembling the people and the material, flaring would probably just last even longer while we make those repairs.
Is there any way to stop the inflow of sludge, so the creation of the digester gas, so the desulfurization facility could be shut down without having gas be generated?
No, the plant is an essential public service, and the digesters are bioreactors, so even if sludge were stopped today, it would actually take quite a few days for the bacteria to stop producing the digester gas, so it's not something we can just shut off.
Will the greater Los Angeles population still be using their sewer system, flushing toilets, using their sinks?
No. Oh, probably no.
Will they still be doing that, whether we're doing
Yes,
these
they would.
repairs or not?
Probably, yes.
Is it the city's intent, as you previously testified, to monitor the emissions if the variance is granted?
Yes,
And in accordance with the conditions of Exhibit A?
yes.
And were these repairs beyond LA Sanitation's reasonable control, or the need for these repairs?
Excuse me, some of these items are wear and tear items. They're things that need to be replaced typically at some point. In addition, let's see, what was the other item? One of them is particularly on a 3-year replacement schedule, and that's the pressure safety valve.
If repairs were deferred and the desulfurization facility shut down to take place at a later date, would there be a corresponding benefit in air contaminants, or reducing air contaminants, rather?
No, that'd just be additional time flaring.
Did LA Sanitation act timely in seeking this variance?
Yes, this is a regular variance on this one.
No more questions for this witness?
Thank you. First, let me just say, Ms. Simons, Ms. Hopisand, the visuals that you presented were outstanding and really helped our understanding greatly. Ms. Reichart, questions for Ms. Simons?
Yes, thank you. Other than the conditions that we've already proposed, are there any other means to reduce sulfur in the digester gas prior to combustion, either in boiler number 2 or the flare?
The only one that I mentioned where we could do something chemically to actually reduce it would be adding ferrous chloride.
Which is already a condition,
Which is already a
correct?
condition, yeah.
Okay, thank you. And in condition number 8, there's a restriction about not adding food, oil, and/or grease to the digestion process. What is the effect of that condition?
Fats, oils, and grease, or FOG, that's added to produce more digester gas. Like I said, digester gas is a fuel. We would like to have that to produce more electricity and steam. So to have that condition in there, we'll just be producing less digester gas. Less digester gas should be less sulfur also.
Great, thank you. And how is the operating time measured and recorded in the boiler and the flare?
Now, the boiler has a SEMS unit that is continuously measuring the flow. So that's something we could pull up at any time.
And then,
And the flare flow, each of the flares has a flow meter, and the flare flow meters feed into our distributed control system, so we have continuous reading on our flare flows also.
so that measures flow as well as operating time?
Yes. Flow is measured directly. We could have, from the readings, we can then calculate the operating time also. It's all, the flows would all be time stamped. So we would know the flow at, for example, 2 p.m. We would know that.
That's all the questions I have. Thank you.
Thank you. Mr. Camarena.
Thank you. First question has to do with exhibit number 3. In your description of what's shown there, I don't recall that you told us what the equipment in the lower right-hand corner is. I'm assuming that's the LOCAT system.
I apologize. Is this it here? Oh,
Is your microphone still on, Ms. Simons?
yes? Okay. Stand close. Oh, that one. Okay, I'm sorry. This one here?
Yes.
Oh, okay, I'm sorry. Would you repeat that question?
The question was, is that the LOCAT system on the lower right?
It's this system over here.
Yes.
You can just see faintly the absorbers over here. This system in the foreground is odor control for the primary treatment
I
system.
see.
Yeah, this was just taken from the top of our office building. It's about the only place we had where we can get a nice overview of everything.
You told us that the orifice plate is, the meter's not accurate. How is it you know that if you haven't opened up the
The readings that we're getting.
readings that you're getting?
Yeah, they're the readings that we got. Like I said, at this point, it's not even functioning right now. But the readings were starting to be not believable.
Oh, okay. Okay, looking at Exhibit A, the proposed conditions. Condition number 2 says that the repair activities on the digester gas desulfurization system will go on for one minimum of 1 12-hour shift per day. Why limit it to 12 hours?
I'm going to defer that to Mike.
Well, you can answer the best that you can, and there will be another witness to testify in greater detail as to the repairs and the length of time.
Let's defer that.
Okay.
On condition number 3, it specifies at least 75 gallons per hour of ferrous chloride. Do you know what the concentration is?
At that, it's approximately about 200 parts per million at that concentration, or excuse me, at that flow rate. Maybe let me give a range, 150 to 200 parts per million at that range.
450 to,
100, oh, I'm sorry, 150 to 200 parts per million.
okay. Any problem in specifying that concentration in the condition?
No, that's going to be fine. The only thing is why it's represented as a flow is we have a flow meter out there that operations can, that's what they're setting and adjusting the pumps to, is to maintain that flow. We don't have feedback on a readout for operations for the concentration.
Okay. Regarding the petition, what you're seeking a variance from is what is spelled out in your petition. Where's the petition? On page 4, item 9, is that, there's 3 items there? Is that all?
Yes, I believe so.
You don't need a variance from the condition number 4 of the facility-wide permit?
Let's see. Yes, that's actually item number 2, or the second item. You're talking about question number 6. It's that second one, the combust sulfurous gas greater than 40 parts. That's our permit, 800-214, condition number 4. So that's referring to our facility-wide conditions.
Thank you.
I have additional questions with regard to the variance relief you are requesting. Just so I understand, you originally, at the time the petition was prepared, you were planning to flare all of the digester gas, is that correct?
Yes, at the time of the filing, yes.
Okay, so now you are planning to put about 30% or so through the boiler number 2, is that correct?
Run the boiler at the capacity it can run, and then the excess would be flared.
Okay, but now you are not adding any rules or conditions from which you require a variance because there is no specific condition for the boiler in the permit, is that correct?
No, it's all in the facility-wide condition number 4.
Okay, but in item number 6 on page 3, which is of the permit, which is the equipment, you have the flares listed. Do you also require boiler number 2 to be listed there?
Yes.
Okay, and do you happen to have a device number for that?
It's on the permit that was distributed.
Okay. I will get that then.
It is. I'm sorry. I do have it. It's permit G 42943. Application number 578356.
Okay, I'll look at it. That was quick. Okay, great, that helps with that. Couple of questions. So it's the sulfur content that we're concerned with. Is there a potential for odor or nuisance due to odor?
No, not due to odor. We haven't received odor complaints related to flaring.
Okay, and is that because somehow it's converted to
The
SOx?
SOx, yes.
Okay. Have you, in the past, had to bypass the desulfurization facility?
Yes, in the past we have, for similar reasons, to do preventive maintenance.
Okay, and you
Or
had,
construction, yeah.
sorry, and you had similar outcomes to what you're anticipating here?
Yes,
And did you use the ferrous chloride in the past?
yes.
Okay, because my next question is, generally, when we calculate excess emissions, and then we agree to deduct based on mitigation, we want to make sure that there's some certainty to the mitigation. So how certain are you that with the amount of ferrous chloride that would be required in the conditions, that you would actually reduce 94 pounds per day of SOx? Is that really an estimate?
That's an estimate.
Okay. And we'll know that for sure based on SEMS readings at the end?
Two methods. We'll have the digester gas flow, and we'll also be taking H2S measurements.
Okay.
And for our calculations, we actually assume 100% conversion to SOx.
Okay. Along the lines of the ferrous chloride, can you look at, just real quick, at Exhibit 1 and just explain briefly, that's this chart which shows the bypass, the schematic. And if you could possibly show us if you're bypassing the desulfurization facility, where is the ferrous chloride added in this process?
Just one sec.
Madam Clerk, would it be possible to display the exhibit?
We're looking at Exhibit 1 schematic. There we go. Oh, right, she has it.
The ferrous chloride would be added right here. It'd be in the inlet to the digester. This is what makes it somewhat unreliable because it's going right into the sewage sludge. And sewage sludge has, there's a lot of variability in it.
That's right. You had testified earlier that ferrous chloride is generally not the relied upon method because the results are not consistent. Is that correct?
Yes.
Okay, so we can't be sure of how much.
That was an estimate. It was
Okay.
also an estimate based on previous times, but they haven't always been the same.
Okay, that was my question. Okay. I think that's all my questions. Any other questions? Ms. Byrd?
I'm sorry, I was trying to take notes during some other comments, but I'd just like for you to clarify one more time. I heard you say there was 100% conversion to SOx, and that's what your estimate
Yeah.
in petition.
Yeah, we're assuming that the H2S is combusted
Okay, so
completely.
this is really a conservative estimate. This is
Yeah.
like the worst possible case.
Yes.
Okay, and then you said something about the, if sludge stopped today, it takes 5 days to do something, and I didn't get that.
Even if sludge feed were stopped to these digesters, these are actually bioreactors,
Okay.
so they
So
will
they have-
not just stop producing gas. There's going to be a decrease in gas over time.
Okay. All right, thank you.
Other questions? Dr. Lerner and then Senator?
I'm not very familiar with flaring, and here, more familiar with from other companies with other products. Is the flare have an opacity to it?
No, occasionally on startup, like the first, let's say 5 to 10, 15 seconds, as the dampers adjust, we have damper control on our flares. Maybe there'll be a little bit of smoke, but after that, no, all you see is actually the thermal print.
Gotcha.
That's the only way you would even, if you're from a distance, that's the only way you would know that the flares are even on.
And the function of the iron that's added, the ferrous chloride, what, does that act like an enzyme or adding does it function to make an enzyme work better?
When it's added in this phase into the sludge,
Yeah.
it's reacting with the sulfide that is present in the sludge itself.
So you're forming ferrous sulfate of some kind?
A ferrous sulfide, a precipitate,
So-
ferrous sulfide. Yeah.
Okay, so it does precipitate out?
Yeah, it be,
Okay.
yes, it
So
does.
that the amount of the amount of sulfur that you take out is proportional to the amount of iron that you add in, but there is some rate limiting factor, you can't add too much.
There are competing reactions with that. That's one of the reactions that ferrous has, is it reacts with the sulfide. But then there are other reactions too. It's difficult. We can't control it to that finally, where it just reacts with sulfide only. It reacts with other things.
One last question, this again is sort of because of my inexperience with this. Is there any place where the H2S can actually leak and get into the air and cause odor in the system, the way it's constructed now?
The way it's constructed now is the facility, the desulfurization facility, does have pressure safety valves, because these are all pressure vessels.
Right.
So if there was a rapid pressurization or a pressure safety valve were to fail itself, gas could escape through a pressure safety valve.
I see. And how close to the population is the plant?
Hyperion's quite large. I want to say we're about 140 acres. The flares themselves, they're approximately, this is an approximation, maybe 400 to 500 feet from our eastern border where there's residential.
Thank you very much.
Exhibit 1. In your discussion of the system's operation, you mentioned that flare will occur under certain circumstances, such as the cogeneration facility, steam and electricity, the process and boiler number 2 were not available. What do you mean by that?
For example, the cogeneration facility is going to be down for maintenance. And then the process boiler, let's say, for example, there was a mechanical breakdown in the boiler, that wasn't an option.
This was normal operation.
Normal operation, yeah.
Normal operation, you mean the cogeneration?
Normal operation, the plant is not flaring,
So only when you have a failure.
only when there's a failure.
And the cogeneration facility, is that, you're not asking for any corrective action to be taken in that regard?
What's happening at the cogeneration facility is it's going through an annual shutdown and annual maintenance, planned maintenance. It is not broken down, but they do annual facility
So all this
maintenance.
being done at the same time, simultaneously, the 4 or 5 days that you're asking?
Yes.
And the process and boiler, same thing?
The process boiler we'd like to put in service.
What? Say it again, I'm sorry.
The process boiler, we're asking, that's the late addition that we had. We'd like to have the process boiler in service also during this, while the cogeneration facility is out of service for preventive maintenance.
On page 3, item number 8, the question that was raised, you have a maintenance program, and then you talked about the plant's preventative maintenance schedule is assessed based on the facilities or broken down into individual components such as pump valves, transmitters, etc. What do you mean by how many parts are you talking about?
Ooh.
The fields,
Hundreds, thousands?
oh, is that
Yeah.
unlimited?
Oh, it's a big number,
Okay,
to the
fine.
point where we have a database maintenance
In
system.
the same paragraph, you talk about, and the schedules for preventative maintenance, replacement of components are established according to the manufacturer's recommendations. industry standards. Is that what's happening here?
For this one, on one of the items that is being serviced at the desulfurization facility, one of the items that's not broken down is, that's part of the preventive maintenance, is the replacement of the pressure safety valve on the inlet knockout drum. When gas enters the desulfurization facility, it goes through a knockout drum to remove water. There's a pressure safety valve on that one. That one is part of a regular preventive maintenance.
And you're referring to attachment 2 of the petition?
Attachment 2, yes.
And that's a 3-year schedule.
That one is a 3-year. Now, for example, if I should do this, in forecasting, in 3 years, this valve will need to be replaced again. But if nothing else needs to be replaced on the main line, this knockout drum is a smaller volume. That pressure safety valve could be replaced in a shorter duration than what we're asking here. This is just going to be work that's going on at the same time as the main shutdown.
In your petition, it was stated that the problems that you're now asking to be considered for replacement was something that was observed. You looked at. What do you mean by that? Somebody walked through the plant and saw the problem?
Well, the operator who routinely operates this equipment noticed that that there was like flow coming through what should have been a closed valve, or they could see an impeller rotating in the counterclockwise, so that they knew that valves were not holding.
So it was not.
So some of it's observable.
So the modification that you requested was not done per a preventative maintenance schedule.
Well, these are things that the isolation valves wouldn't have been, or no, they were not part of a regular replacement schedule.
Isolation, point to it again, isolation valve.
This one.
And for the record, this is attachment 3 to the petition?
Some items are as needed, and in this system, this is the LOCAT solution system. This is the liquid portion of desulfurization, and up here we have flow control valves, and this is typical of all 4 lines. We have a bypass line, and these valves are not holding. They're not.
During the operation of the system, you got a pressure and pressure rod.
I'm sorry.
Pressure.
This is a pressurized system, yes.
Right.
The gas is operating at about 35 to 40 psi. The gas is coming in. And off the top of my head, I don't know what the liquid pressure is, but the liquid is also, it's pressurized to overcome the gas
The
pressure.
flow control valves must be operational with the highest efficiency at all times.
Yes, to be efficient, yes.
Right,
It's
be
for process
efficient.
control.
You have a preventative maintenance program as it relates to the flow control valves?
Well, in this case, we have 2 units available. So if one of these is out of service, one of the other units can be available, or one of the others could be run. And then while this one is out of service, it could be isolated and removed from service and replaced.
How do you determine that it's out of service, that it's not operating efficiently?
There are flow meters on this line, they can't control the flow.
You observe that, is what you're saying?
You can observe it on a flow meter, for
Look at the meter.
example. You can get a readout back.
What would happen to the system if it fails, the control valves are not performing efficiently, and when one is out, the other doesn't trigger, that's out also?
In that case, there would probably be a high H2S.
Be what? High H2S?
High H2S, yeah.
And then when that happens, what happens?
At that point, At that point, it'd be like a breakdown notice, and then a repair would be initiated.
You're very knowledgeable about this system. Has that happened before?
There have been yes, there have been breakdowns at the LOCAT facility for various options and for various items. And so, yes, when there is a breakdown, it's a call-in report, and then we have 24 hours to correct it,
So
or at least get back into compliance.
when you have that breakdown, then you're out of compliance. Is that correct?
If you have a breakdown, it can result in a
Out of
non-compliance.
compliance. And what do you do when that happens?
In this case, it would be like.
What do you do when that happens in terms of notifying the district?
For within 1 hour of discovery, it'd be a call-in that it's out of compliance.
You
Just,
ask-
just to clarify, there are rules that, for breakdown, that have the requirements that you're following, is that correct?
Yeah, there are established procedures if you're not going to be in compliance with the permit. And if there's a breakdown, then there's
you.
a call-in for that.
On attachment 3 also, you discussed in detail the check valve problem. That's one of the things that has to be replaced.
Yes.
And how does that work with the junction with the flow valve, if at all?
What the check valve does is it prevents flow from going, it ensures that flow goes in one direction and not back the other. Because you see there are two pumps?
I see that.
Okay, there's typically one in service, one standby. And so when one is on standby, that check valve prevents the in-service pump from pumping into that pump. It keeps it going into the system.
One is always going to be on standby, and then while the other one's operating?
Typically, it's one online, one standby, but depending on H2S, how much there is in the system, a second unit can be put in
They
service.
both operate at the same
They
time?
can. They typically do not, but they can.
Is that a requirement?
For this desulfurization facility to
Both
be
of them operating?
no, it's to meet the standards to
It's just a safety?
40 parts.
Okay, my concern then was that if you have a maintenance program, which reminds you when a component is to be replaced based on a preventative, right? This is a reliability program, what you mean.
It's a reliability program.
Reliability program. Is the district, do they have a schedule of they have a copy of your schedule of reliability program as it relates to operation of the system?
Probably not, no. That's, like I said, that's in our database.
It's in your database?
We have a
So therefore-
database of work requests and a preventive maintenance
So
system.
it's predetermined when parts will be replaced based on your reliability program, is that correct?
Yeah, it's parts to be replaced, calibrated, other
Calibrated.
checks, lubed. There's a whole variety of different types of preventive maintenance items.
So that 3 months time delay should not have occurred if you had a program that's actively being complied with.
Well, some of these items would be, even a manufacturer would say run into fail on that one. Because some of these valves could even be like 30 years old or older. Some equipment just doesn't have a regular fail. And preventive maintenance doesn't always mean replace. It means to service and
I
check.
understand, serve before it fails,
It's trying to get before it fails. Yeah.
before it fails. Let me just say that the city of LA, you work for the city, right?
Yeah.
Should be proud of you. You've done a good job as far as I'm concerned, explaining the whole system's operation in detail. You know it very well.
I hope it was clear. Thank
It
you.
was very good, in my opinion. The best I've had since I've been here in terms of a complete description of the system's operation, knowing all the details of each component's function.
Yeah, I'd just say, like, for example, like I said, this is our plant example here, but even for your car, you have your preventive maintenance schedule. You change your oil, you check your fluids, but you don't replace your engine at 60,000 miles, just because maybe they only last until 60,000. You wait until the engine failure on something like that.
And the Exhibit A, District's Exhibit A, on item number 2, they talk about,
That's the proposed,
I'm sorry,
proposed conditions. I'm not sure if you have that with you
I
up
don't
there.
have it with me, but I read it before the,
they wrote 4 days.
yes.
In your petition, you said you might need an extra day.
I think that was, it was included into the 4 days. We think we can get this done
No,
within
no.
3,
Yes, it is.
4 days?
It says you need 1 day, 2 to 3 days, 4 days return the system to service, and then 1 day factor of safety is scheduled, or already
It
included.
is included, and I'll let Mike speak to that. He's our plumbing, or pipe shop supervisor. I included in that day 2 and 3, the estimated work is to take 1 day, but there's a factor of safety in case not everything is, in case there's a leak or everything cannot be returned to service. And he can address that.
And you have here in number 3, where you say the petition shall measure and record the quantity of ferrous chloride used on a hourly and daily basis. And then number 7E, the amount of ferrous chloride additive used in the digester. Why is that so important? Both of them, they're working together, but how is that so important?
Those are both for ferrous chloride. One's just asking for the hourly rate, and then the other condition, I think, is asking for a total for the day.
Why do we need to know that?
It's, informational, to make sure, at least on the hourly basis, it shows that we're continuously adding instead of, just doing something at midnight.
Couldn't that be an indicator that something is wrong with the system if you have an excess more than what you think should be in there?
No, it's visually, no, we would not have an indication that there are problems with it. That's just something that needs to be monitored.
Thank you.
Any other questions? And if not, we will take a short break. No other questions? Thank you, Ms. Simons. We're going to take a 15-minute break, and we will come back at 20 of 11. And perhaps in the break, if you get an opportunity, I believe Mr. Camarena had asked whether you would be willing to specify the flow in condition number 3, and perhaps, am I correct?
Concentration.
Concentration in condition number 3. Perhaps if there's some idea of wording for that, that would be helpful. So we're off the record, and we'll be back on the record at 10:40. We are back on the record, and I believe, Ms. Hopenstein, you had a second witness.
Yes, actually, before calling the next witness, I was hoping to recall Ms. Simons to address some questions that were asked before the break.
Yes, that would be fine. And of course, Ms. Simons, you recognize you are still under oath.
Yes.
Ms. Simons, there was a question pending about whether concentration can be guaranteed as an incorporated into a permit condition. Can you please respond as to that?
Yes, we don't have a continuous readout for the concentration. We do have for the flow. And the raw sludge, it doesn't vary too much over the day, maybe about plus or 10% from day to day. So we could, at the end of the day, we could look at what our concentration is and adjust the pump flow to meet that. But we just don't have that direct readout. We'd have to back calculate, given the raw sludge flow, we'd have to set the pump that, and that's not automatic, that's adjusted.
Okay, Marina.
Do you purchase the solution or make it from, prepare it yourself?
It's purchased.
And there's no guarantee as to the concentration?
There's a range, yes.
Are you referring to the concentration in the solution itself, or once
Yes.
it's been added? He's referring to the concentration of the solution,
Oh, yeah.
not once it's been added to the sludge.
Okay, the pure solution, yes, that's set.
Okay.
I mean, in our specifications, there's a range, but the range is maybe like plus or minus 2%.
Okay, so what you purchase, you know what the concentration is.
Yes.
So what changes?
Oh, in this case, the raw sludge flow. The raw sludge flow is not continuous.
Okay, so.
So as the raw sludge flow goes up and down, to maintain that, in this case, to track that flow, then the ferrous chloride pumps, the addition would have to track, it'd have to be flow paced with the raw sludge flow
So what changes is the flow rate,
of the raw sludge.
but you would have no problem with the concentration
We could calculate the concentration on that.
of ferrous chloride in,
We can calculate the ferrous chloride concentration in the raw sludge.
I was talking about the ferrous chloride in what you add to the raw sludge.
Oh, I'm sorry, that we could measure in the laboratory.
But what you purchase doesn't change.
Oh, there's always a little bit of range.
That's not appreciable.
No, it's within, we have specifications, and there's a concentration range that's allowable.
Thank you.
Senator?
I hate to have you come back, but there's one exhibit 4, I didn't get a chance to ask you a question on that one. If you don't mind, please.
Yes, would you like me to come up, or?
Yeah, please, sir. You already discussed the flow rate for the gas, and that the orifice meter. You already talked about that. But the orifice meter is, when you look to your right, you're going to place the orifice plate. That's what I think you said you're going to do. We'll install during this fix.
It's inserted in here.
You say, while you're making these repairs, you said.
Yes, yeah.
Pardon?
Yes, it'll be,
You said you would install the plate, orifice plate, during this downtime.
yeah.
Okay, then when I look at the plate and how it's installed, you have a upstream, you have a flange union. You can see that, and I can see that also. Downstream, you have a flange union. You have the gaskets there on both ends of the side of the plate. This plate is mounted in some well mounted there. Is that wear? Did the plate wear? Is that why you have to replace it? Why do you have to replace the plate?
In this case, we're getting readings that are not really physically possible or believable. And what can happen on this is this material on the plate, it can corrode, it can pit, and that will affect the flow measurement. So if you look above, typically how they're engineered, this is a cross section of one, and even the it's not a perfect circle. There's even on the edges are angled.
This plate can corrode?
Yes.
What material is it made out of?
Digester gas, which has sulfur in it. Yeah. Yes.
The plate is made out of gas?
Oh, no, it's measuring gas. It's in contact with sulfurous gas.
What's the material?
Actually, I do not know the material on this one. I can't
How often
testify
do
to
you
the material.
replace the plate?
It'd be as needed. As far as I know, this will be the first time it's ever been replaced.
How do you know when it's needed, when it's locked in between these two?
From the readings,
flanges?
from readings that we get, we know that there are problems.
So if there's a problem from the reading for
The readings that
flow
come
of the
back.
flow,
Yeah,
if there's a reading from the orifice meter,
yes.
then you say that's got to be the problem.
Yes.
Or are there any other reason why there'd be a
So
problem?
they did things where they check calibration and the components going in, and it's, like I said, it's just not
So
making
you
sense.
disassemble the flanges and you put a plate in
That's what's going to
based on the
be.
readings. If you get a faulty reading,
If there are faulty readings that cannot be corrected or cannot be explained, yeah,
so you assume that therefore it's the plate.
yes.
How often do you do that?
This will be the first time I think this one's ever been done.
In how many years?
I actually do not know how old that component of the system is.
But you feel that's the problem.
Yes.
Thank you.
Did you have other questions, Ms. Hopenstam?
Yes, two. More for clarification of the record. There has been in the proposed conditions included that some monitoring required of the hydrogen sulfide, and that would be in both the boiler and the flare. Is there a condition existing on the city on how to do those measurements?
Yes, it is. It's in the city's facility-wide conditions.
And that was included as an attachment, the permit?
I don't know if it was on, I only included item number 4. I don't know if that,
Let me reflect.
can you take a look, at maybe condition 5 or 6?
Let me refresh your recollection, and if I can present to you a copy of the petition. And you're familiar with the petition?
Yes,
And because you worked on it?
yes.
Okay, 1 minute.
Yes, it was included with the original petition.
And what was included with the original petition? Could you explain?
In this, it's a facility-wide conditions. It's page 4 of Hyperion's operating permit. And condition number 5B, it sets up the conditions for H2S monitoring when the H2S is above 36 ppm. And during this variance, the plant would be above 36. So we're looking at this measuring or monitoring H2S according to this method, what's laid out in B.
And while you have the petition in front of you, I don't think there's a need to redisplay it, but if you could turn to attachment 2, we've had a number of discussion, a lot of discussion on that attachment. Is there anything on that attachment as you take another look at it that should be updated for the record?
Yes, this is on attachment number 2. And, I'm sorry, and these documents were coming from our training manual, and I realized that our training manual needs to be updated because at the end here, it shows the digester gas going to scattergood. That is no longer occurring right now. The plant is combusting digas on site in its own cogeneration facility.
Is scattergood any longer an available option to send digester gas to from the facility?
No, it's no longer a viable option.
Okay. No further questions for this witness.
Any further questions on the new testimony? No. Okay, thank you, Ms. Hope, and thank you, Ms. Simons. Thank you. Ms. Hopenstand, your next witness.
The city would like to call Michael Wise. Mr. Wise, if you could please state and spell your full name for the record. Make sure your microphone is on.
Michael Wise, Michaelwise.
Mr. Wise, what is your position for the city and your job duties generally?
I'm the plumbing supervisor for a Hyperion water reclamation plant.
And do you understand that you are under oath today?
No.
Are you under oath?
Yes.
And as the plumbing supervisor for Hyperion, do you have any role in some of these repairs that were part of Ms. Simon's testimony that you observed today?
Yes, I supervise a crew and that will make the repairs or replacements for this variance.
And the crew that you're referencing, about how many people will be conducting these repairs under your supervision?
I supervise crews of 25, so we have a set of 2 crews, or like a crew 1 and crew 2.
And how many hours will crew 1 and crew 2 be working?
We'll probably break up the 1 crew. It'll be working 12-hour days, approximately, A and B crews.
So does that mean A and B are working concurrently each 12 hours or over a whole 24-hour period?
Over a 24-hour period, I'll work a night crew also.
And are your employees already pre-approved for overtime on this project?
Yes.
And there has been some testimony generally about the repairs. Can you be a little bit more specific about what repairs are being conducted during this requested shutdown of the desulfurization facility?
Yes. The recirculating pump is for the solution. The 2 check valves out there, we will replace the check valves downstream of the recirculating pumps. And then from there, off the main line that goes to the control valves for the venturi and the absorbers. So they have a inlet valve, a bypass valve. So we'll rechange on, for train A and B, those valves off the main line header.
I think it might be helpful if you wouldn't mind returning to the projector with attachments 2 and 3 and explaining on those documents where these repairs are going to be taking place, please. And while we're waiting for you to set up there, Mr. Wise, there are a number of photographs that were in a plastic folder that were handed to the clerk. We're also going to be asking you to provide some testimony on those, so perhaps those can be distributed as well. Okay, Mr. Wise, are you ready? Yes. You mentioned that there are some recirculation pumps that you're going to be addressing, control valves, bypass valves. Can you please indicate using these documents what the different repairs are and where they're located?
Yeah, so as on the diagram here.
Mr. Wise, can you just pull that microphone to you and speak directly into it? Is it on?
Yeah, it's on, yes.
Thank you.
Yes, so the check valves on these 2 recirculating pumps here.
And you're looking at attachment 2 to the petition?
Attachment to, attachment
Oh,
3.
attachment 3, thank you.
So downstream of each recirculating pump is a 8-inch check valve. And we'll be replacing those 2 check valves. Looks like they're original check valves in the system. So they've been in there for 25 years. So due to the wear and tear on them, they need to be replaced. Like I say, it avoids, without check valves on, when the valves don't hold downstream, the pumps could turn backwards and create hazards. Downstream along that, from the downstream, we go to the lines to the absorbers and the venturis, these control valves, but each on control valve before them is a block valve and a bypass valve around each control valve. And so we'll change out the block valve and the bypass valve on each venturi A and B, and an absorber A and B. So we change out those. So that allows in the future, if we replace the control valves, it avoid any shutdowns. Operations through their process to the work, I have noticed that some of these valves are not holding, so they generate a work order for a corrective replacement. And so as a preventive, so the other ones that they didn't make corrective workers for, we'll change all for each system. The absorbers and venturi safety valves on train A and B, we'll change out all those 8 valves on that one, and then also 2 check valves. And then the other part, it would be the orifice plate. So, and that we'll replace that orifice plate, and then it also has 2 purge ports on there, the major differential, and we'll make sure all those ports are clear, because that could be inaccuracy if they get a little bit of clogging. For the sour gas, is not a clean gas, so we'll make sure those ports are clear.
Is the orifice plate something that you can point out on attachment 2 to the petition?
On this drawing here, FIT 503, there's an orifice plate right here. This pointer.
And a knockout safety valve, is that something else that's going to be addressed?
Yeah, and that's on an unfired vessel, and it's usually a 3-year vessel inspection, and part of that is a recertification of the valve. So we send it out, have it certified make sure everything's functioning correctly as a safety valve item. So, and because this vessel's unfired, it's a 3-year requirement.
What if these repairs are on the main line to the facility, meaning they necessitate a shutdown?
It means because of our hazard assessments, our safety program requires the system be shut down, because we'll have a lockout, blockout, we'll have a permit and a hot work permit. So these work will require a hot permit. So it means spark producing tools. And because it's a gas line, and the gas line is linked to the absorber where they do mix together. So we need a purge, isolate and purge the systems out.
Let me break up the testimony a little bit. Which of the repairs will be on the main line for which you're concerned about the hazard issues?
Okay, the orifice plate, because we're going to may have to cut and grind on that to get some of the bolts off. Looks like it's original. And so we'll have to cut and grind there, and so that's to replace that orifice plate. And then on the other part is the solution on the recert pumps, those 2 discharge check valves. Because of the capacity of these pumps, they produce 1,000 GPM. They operate between 100 and 170 PSI. So having a single butterfly valve as an isolation point, it wouldn't be safe enough when we're removing the check valve. The check valve in there, if they're function new, it allows another sealant point of security there. But and that means it's on the main discharge line.
And I'm going to distribute some photographs that I would like marked, just so we can get additional visual aids for some of these repairs, and then we'll ask additional questions of you, Mr. Wise. Yeah.
We've received 5 photographs. I'm not going to try to distinguish between them. I'll allow the testimony to do that, so I'm going to mark them all as a package. Exhibit 7 is the next, is that correct?
Okay.
Okay, I'm going to mark them all together, all 5 photographs as Exhibit 7.
Mr. Wise, if you could take a look at these photographs and let us know what we're looking at.
Okay. This photograph here, this is the recirculating pump, and this is the check valve that we'll be replacing. This will be the normal isolation valve on it, but as you can see, these are large capacity pumps with high pressure, and this is only boundary, isolation boundary, so it's for safety reasons. Both pumps should be off, only because we're changing out this check valve. There's no other, as these pumps produce 1,000 gallons per minute at over 100 PSI pressure. So that would be the only safety item there, and it's for a lockout problem, it would require additional isolation. So at this point, we'll have to disconnect the electrical on these pumps and then make it safe, and then the solution will have to be drained out.
If you could walk us through each of these photographs, and then we'll ask a number of questions after.
After it leaves the pumps, goes past the check valves, these are these valves that for the Zorber and the Venturi. This is the control valve right here that normally controls the flow to 50 G onto the sprayers, to the Zorber. And then these other valves here do the Venturi. So they have flow rates of 50 on one and 450 on the other. But I'm going to be changing out these bypass valves and these inlet valves on this system here. Only doing that during operations normal process, that some of these have failed and they leak through. So it makes it harder to control the flows with these valves starting to fail. So we'll be doing all these valves, each one on each system. That way it'll avoid for any future shutdowns of the equipment there, because it is on the main supply line upstream of these where it separates from train A and B.
Is the significance of it being on the main supply line that you need to shut down the facility? There's no other way to do the work on this?
No, because it's the main supply line that supplies fluid, the solution to both trains, and these are the valves that would separate train A from train B.
And train A from train B, are those process trains that one's on and one's on standby?
Yeah, they could put either both online or like A or B train online.
But a main line, a common line?
Common line, supply line to it, that means that everything has to be shut down.
What's the next image?
The next one, this is just a picture of the orifice plate. So, I say the engineers specify the ID there. It's usually made out of stainless steel, 304 is usually the.
I'm sorry, the orifice plate,
Yeah.
the big round thing.
Yes, the round item, yes, with the tab on it. The tab will identify the opening of the port of the orifice there, and it has a flow direction on it. And off that, it receives pressure differential taps on each side of it. And so I'll make sure those taps are clear also at the same time.
The senator has a clarification
Did you
question.
say stainless steel?
Yes,
The plate?
yes it is.
That's corrosion resistant steel?
Well, some of the chemicals in the gases system are very corrosive, but it could have a wear or
Corrosion resistant, it doesn't rust.
yeah, 304 has more nickel in it.
But she said it rust, that's why I'm
Well,
asking the question. Okay,
it's-
carry
it's-
on.
I'm sorry, it's a stainless steel, but it can have some wear on it though.
Mr. Wise, there had been testimony about there being possible corrosion on the orifice plate. Would that corrosion have been from components in the digester gas as opposed to, let's say, water? Or what's your understanding?
Digest gas is a wet, dirty gas, so it's not a very clean gas. So it could be some buildup there or possibility. And in the ports that read the core, the differential, there could be some restrictions there also, and that I would clear out at the same time.
Could the gassing cause a problem?
Sorry, Senator, do you want to hold your questions, or
I
is
can
it
hold it right
clarification?
here, but go ahead, carry on.
Okay. this is the last photo I have. I didn't have it. Apparently, I have the last one. It just shows the sour gas line as it goes up to the orifice plate. This drawing here, and this just happens to be a bypass valve at that point there. But from this point on, it is going up to the orifice plate.
Returning to the corrosion question, does resistant mean no corrosion or less corrosion?
Less corrosion.
I'm sorry, Mr. Weiss, you're a little further from the...
Less corrosion.
Okay, thank you very much for walking us through these images. There was some terminology you gave, knockout or lockout, knockout. What does that mean?
We have a safe work program. And each employee is required to go through a hazard assessment before we're able to work on equipment. And what that requires is, before you start on a piece of equipment, you look at the hazards associated with it. So it could be electrical disconnect, or it could be like the gas line. If we're going to operate, make sure it's isolated, depressurized, and the gas is removed from it or purged from the system. And for each system, and as a solution, it must be drained down and then flushed out because of the hazard of the chemicals in there. I think this one has ARI 300 and KOH, potassium hydroxide. So those are at 50%. That's quite hazardous chemicals to have employees near. So we need to drain it and then flush out these systems before it's able to work on.
You also mentioned a hot work permit and the possibility of sparks. Can you explain the significance of that in the context of some of the repairs you need to do?
As part of the hazard assessment program, we have a lockout blockout. In other words, they isolate and they tag the systems. They're purged or flushed. And then anything that you're going to use a spark producing piece of equipment, be grinder, torch, or anything that produces a spark. And so to eliminate any hazards of explosion. So we get a hot work permit, and that sets a requirement for isolating and purging systems.
And this facility that treats digester gas, is digester gas potentially explosive when it's in contact with sparks?
Yeah, with the sour gas being a methane gas line, above 5% becomes explosive.
And it's your understanding digester gas has a composition above 5% methane?
Yes, it is.
In fact, 65%?
5%.
Why is there a 4-day estimate to complete this work?
It will take operations, once they start, they need to isolate all the valves. They must drain the solution out of the systems, flush it out, and then they need to take nitrogen, hook all the hoses up to the purge points there, and then purge out the gas that did not go to the flares. And so it needs to be purged out of the system. And then once they read with gas techs, they'll read it and take readings and see where it's at. That is usually everything we read is that we'll measure the oxygen, the hydrogen sulfide, and then we'll also measure the combustible levels with gas detectors.
How long is the purging and readings that you just described intended to take?
Most likely it's probably going to take most of the day because it's going to take a few hours to drain all that amount of solution. They want to recover that solution, so they'll pump it into tanks. And then once that's done, then they'll start purging any gas left in the vessels or in the gas line. So they'll purge it out with nitrogen.
And what's your best estimate when you say most of the day? About how many hours for this part of the process?
It's probably going to take them a full day to do that process there.
Is full day 8 hours, 12 hours, 24 hours?
Up to 24 hours.
And how long are you estimating for the work, the actual repairs to be conducted?
Repairs I expect to take one full day, but once you break equipment apart, unforeseen repairs could come up there, and so that you may need additional time. I may need additional time for that.
Is that the factor of safety that Ms. Simons testified to earlier?
Yes, you never know if I have to order material or have something fabricated.
And after the purging and the readings are conducted and the repair work completed, including possibly dipping into your safety factor, is there any other time that needs to be spent to, for example, re-energize the units?
Before they re-energize it, I'll purge the system with nitrogen. We'll do a soap test on all the repairs in the system. And then once I'm sure that there are no leaks in the system, it's tight, Then after that, we'll release our clearances for operations to put the unit back in service. So, and then they will slowly, they'll have to put the solution back into the absorber units, and then they'll have to then turn back on the valving to the sour gas lines. So that may take a few hours to a day to do that, reactivate the system.
And again, you're looking to up to a 12-hour period of time?
I imagine it's going to take more than 12 hours to do that because, like say, the electrical and the pumps have to be disconnected, and then, like say, there's lots of, and the solution going back into the system may take some time.
From your work at Hyperion and your capacity as the plumbing supervisor overseeing all this work, do you believe 4 days is an appropriate estimate and a not to exceed estimate of time for this work?
Yeah, we figured in the safety factor. We do not expect to go over 4 days.
Okay, no further questions.
Thank you. Ms. Reichart, do you have questions?
No questions for this witness.
Board members, any other questions? Ms. Byrd?
I just had one. I believe Ms. Simon said something about all equipment for replacement had been ordered or fabricated as needed and on-site, but it sounded as if you said something about there may be some need to order more equipment.
As you break in a piece of equipment that, you may find another leak or there may be corrosion because it's carbon steel pipe and with the moisture in there. If we find something that's, we have ultrasound units. If we see something like it's a leak or something like that, then we'll want to make sure repaired.
So
If it's a threaded fitting that something could break off, you may need to get a machinist back in there to remove that piece or like to re-drill and tap it.
okay, so your testimony is that whatever needs to be done, if it's a necessary piece of equipment or whatever, everything's still going to be done in those 4 days, even if you find something broken?
Yeah, that safety factor that's included in there.
Okay,
That would include, if we have to purchase something, that would give us time, because if it happened during the nighttime that we find it, we'd have to wait till place of business is open up that we could purchase something if we had to.
okay, well, you're committing to 4 days, I'll take that.
Senator, did you have additional questions?
Back to the diagram.
I don't think I
That's
have that.
Exhibit 4, I'm
So hold
sorry.
on, that's Exhibit 4, and I'm not sure if you introduced it. You may need to retrieve it from Ms. Hopenstown.
Yeah, I don't have that one.
Look at both this and that diagram, Exhibit 4, and part of Exhibit 7. We have this plate, it's called the orifice plate. And you were saying that it corrodes.
It's stainless steel. It could erode or something more like that.
Erode, not corrode.
Yeah, erode, yes.
That's the difference.
Mr. Wise, I'm sorry. I know you're trying to maintain eye contact, which we appreciate, but if you could just try to maybe stand behind the microphone, that might be easier to catch your voice.
Erode or etch, is etch?
Yes.
It etch.
Yeah, it could be cut a little bit or have some debris stuck on,
It does etch, you're saying.
It's stainless steel. It's pretty,
Strong.
yeah, it's pretty durable metal. Not often do you see it, but there is some acidity of the digester gas. It could be some pitting on there, or it's a sharp edge on that orifice plate, so it could be a little bit of a erosion or
How long have you worked for the city in this project?
I've been with the city 30 years.
30 years. You ever had to replace the orifice plate before?
Usually it's for recalibration. They put it in there because they want different flow rates out of it. So if the flow, they're looking for something different.
Oh, you changed the orifice plate to treat it to acquire a flow rate that you want.
They
Turn it in and
may
out, yeah.
change the
Flow
system.
rate on this system.
Yeah, they may change the systems. At times maybe the pressures might be different and the flows through a system. It's not often that we change orifice plates.
Well, okay, you guys, it's like a manifold. You got this flange unit, it's like a manifold, and you have a gasket. You ever determine any leakage in that area?
Well, actually, we look like there's a little corrosion right here at this point there, so we're gonna replace that at the same time. So a little spot right there, looks like there's some corrosion going on, so we're gonna change that out too. And these are these ports that measure the differential off each side of that orifice plate.
What's the likelihood of the gasket not?
Those gaskets are flexitalic type gaskets. It's a metal ring with a,
Metal?
you know, they're metal gaskets. Ones each application may be different. There are different types of gaskets, from metal gaskets to garlock or a composition type material gaskets.
Yeah, what is that material of the gaskets?
But now,
Material of the gaskets.
this one here, we're going to use stainless steel flexitalic gaskets on it.
So the gaskets have a longer life than the plate.
It's a 304 type gasket material. So yeah, it's going to be about the same material as the orifice plate. Yes.
So the plate's more likely to fail or deteriorate or etching there more with the gasket.
The gasket, depending on the pressure rating of the and the type of systems it's in, a gasket is made of a composition or metal, depending on what it's flowing through it. And this time we're using a flexitalic type gasket.
Okay, you also,
It's a metal gasket with a composition material in between each little winding of the metal.
thank you. You did revisit attachment 2 in your description. That's this one. Is that like, you talked about cogeneration in Exhibit 1, and this appears to be a redundant system. Attachment 2 is redundant.
You talking about absorber A and B?
Yeah. So if both of these systems are working, then that's cogeneration?
These systems go to cogeneration, yeah.
Right.
This is scrub gas, yes.
Okay. And if one should fail, like, for example, inlet knockout drum,
Well, the inlet knockout.
that takes care of both of those two systems.
Yes, the inlet knockout drum removes the moisture going in, but it's a common line that goes to train A and B. It's before the trains are separated.
If that's a source of digestive gas. If the knockout drum is not working, none of this is going to work.
All this is working, but it's the main supply line to both absorbers.
I know, but if that's not performing,
They're not able to take readings from the orifice plate correctly. It's inaccurate. That's what they're telling us.
when you traverse the direction from the knockout drum to each of these systems to your right,
Yes.
they're feeding both of them. That's a redundant system.
Yeah. When it goes from the knockout drum, it goes. I don't know if you can kind of follow along on the diagram here. It goes to the venturi.
Okay.
And then from the venturi, the gas enters it, but also from the venturi is this low-cat solution coming onto the inlet of the venturi at 450 gallons per minute. And so what it does, it mixes with the gases, and then it goes into the absorber.
And you have two absorbers, you have two venturas.
And as the gas goes up to the absorber, there's sprayers at the top at 50 gallons per minute. And the sprayers kind of help knock down the sulfur.
You have two outlets, knockout drum.
Yeah, and then from there it's
A and B.
So you got to train A and B and say it's knockout drum A and B also.
Why do you need A and B? You got A and B on a
So A and B trains are actually separated, so you could shut down one train to work on and B train to work on. So there's no out of service for the system.
and they both can operate at the same time.
They both can operate at the same time.
Okay.
But being the work that we're going to do today, or this hopefully do, is the common line to both train A and B.
Thank you.
Any other questions? Thank you, Mr. Weiss. Mr. Weiss. Any other witnesses, Ms. Hopenstan?
No other witnesses. I did have a clarification for the board regarding the petition, if you'll indulge me. Question number 9 in the petition on page 4 identifies all district rules and/or permit conditions from which a variance is being sought. And although number 6 on page 3 of the petition indicates condition 4 of application permit 800214 is at issue here regarding the sulfur content of the digester gas. We'd like to make it clear for the record whether it needs to be a formal amendment or just clarification for the board that too should appear here in number 9. That is a condition from which relief is being sought as well, and does appear elsewhere in the petition as well as in the testimony today.
Thank you for that clarification. Any other witnesses?
No other witnesses.
I'm going to ask, Madam Clerk, could you put back on I think we're off of that. Ms. Reichart, any witnesses for the district?
No witnesses unless the board has any questions.
Board members, any questions you'd like answered by the district? Seeing none. I'm going to ask, I guess at this time, if there is any member of the public who wishes to be heard on this matter. And seeing none, Ms. Hopenstan, would you begin your closing?
Just brief remarks. From the evidence presented here today, the city submits that the different findings have been met, that without a variance, the city will be in violation of district rules and a facility-wide permit condition if it shuts down the desulfurization facility to perform the repairs. The digester gas sulfur levels will be out of compliance. Due to conditions beyond the reasonable control of petitioner, breakdown or some visible damage to equipment, resulting compliance and disallowance of a facility shut down for repairs would result in an arbitrary or unreasonable taking of property or the practical closing of a lawful business where the facility break down and be inoperative due to the inability to timely address these repairs. The City of Los Angeles will continue to use the sewer system, whether or not this facility, the desulfurization facility, is online or offline. That such a closing or taking would be without a corresponding benefit in reducing air contaminants. If anything, it would ensure greater emissions. With timing the desulfurization facility with a planned this shutdown for repairs, with a planned shutdown of the cogeneration facility, that's just one of the several ways LA Sanitation seeks to minimize overall increase in flaring and associated emissions if the facility were to go offline due to either repairs per variance at a later time or if an unplanned breakdown rendered the facility inoperable with the chance of a longer period of its being out of service. That there's no option for curtailing Hyperion operations. As I mentioned, the sewer system is going to continue to be in use. And during the period that the variance is in effect, applicant, City of Los Angeles, LA Sanitation, will reduce excess emissions to the maximum extent feasible and is agreeable with the district's conditions presented in Exhibit A. During the period the variance is in effect, the city will monitor or otherwise quantify emission levels as requested by the district as well. LA Sanitation's actions to seek a variance were timely and reasonable under the circumstances, that upon learning of the need to conduct some of these repairs that are coupled, frankly, with just preventative maintenance to take advantage of the shutdown as well, LA Sanitation took immediate action to procure the parts, valves, and engineered equipment requiring fabrication, and has come to the board in sufficient time to also have this shutdown coincide with another planned shutdown as a further way to minimize the impact on the environment. And an unreasonable burden would be imposed upon the petitioner if continued compliance were compelled, notwithstanding the need for the repairs and the good cause shown. Thank you.
Thank you. Ms. Reichart, your closing.
Thank you. Subject to compliance with the proposed conditions, the district is not opposed to the granting of this variance. Thank you.
Thank you. Mr. Camarena, would you like to begin the discussion?
Sure. Petitioner is presently not in violation, but will be in violation of 431.1C2 and 3002C1 and 203B, as well as condition number 4 of the facility-wide permit. That will occur when the desulfurization system is disconnected in order to do some maintenance and repairs of various components of the system. Regarding finding number 2, if the maintenance isn't done, eventually there'll be a failure, which will result in greater emissions to the atmosphere because there will be greater time for flaring of the digested gas. For this reason, compliance is beyond the reasonable control of the petitioner. Denying the variance would result in a shutdown of the sewage plant, which in turn would be an unreasonable taking of property. Further, I would point out that this is a public agency operating an essential public service. Closing would be without a corresponding benefit in reducing air contaminants. The excess emissions will be mitigated by the addition of ferrous chloride, resulting in a reduction of excess emissions that would otherwise occur if ferrous chloride were not used. And when we compare the emissions with the mitigation, they are small compared to the impact of shutting down the plant. Petitioner is given consideration to curtailment in lieu of seeking a variance, but curtailment will not cure the situation. Maintenance and repairs need to be done. Petitioner will reduce excess emissions by the addition of ferrous chloride as specified in the proposed condition number 3, as shown in Exhibit A. And during the period of the variance, the petitioner will monitor the operations by means of the monitoring and measuring equipment and sampling that will be done. That concludes my findings.
Thank you. I agree and have nothing to add. Anyone else want to add to that discussion? Ms. Byrd?
I just wanted to add that it always, well, in my opinion, it always makes sense to take advantage of when there's a plant shut down or a turnaround, and that was taken into consideration this time so that it can minimize the problems and minimize the potential for emissions. So I think that was a good idea at this time on behalf of the city.
I would say I would add, thank you for that addition, to conditions beyond the reasonable control of the petitioner. Not only is this maintenance necessary based on some readings that they're having, based some of the equipment showing that it needs to be replaced, and other maintenance being done on a cycle that has already been predetermined, but also the plant cannot be shut down. As was described to us, you can't stop people using their toilets, and so the actual plant can't be shut down, which obviously goes to curtailment. But also, there are all of these reasons why they must shut down the desulfurization plant, the hot works that are going to be taking place, the flammable gas that is a necessary component, etc. So there are reasons why it's beyond their reasonable control to not shut it down. Any other discussion? Mr. Camarena, did you want to offer a motion?
In the matter of LA City Sanitation Bureau Case 1212-37, I move that we grant a short variance, the commencement thereof, I didn't get.
We actually have a typographical error. Apparently, on number 24, the request should have stated April 30th, but indicates May 1.
So what they're asking for is 4 consecutive days, or no more than 4 consecutive days between the period of April 30th and May 31st. And the 4 days, I believe, would be commencing in the notice given in condition 4. Is that correct? And ending with final compliance in condition 11. We'll just make sure confirm that that's correct.
That'll be the period of the variance in my,
And
I see
that is
yeah.
correct.
Thank you.
that'll be the period of the variance in my motion. And the equipment is the equipment specified on page 3 of the petition in this matter. The variance is from Rule 431.1C2, Rule 3002C1 as it applies to condition number 4 of the facility-wide permit, and Rule 203B. The short variance conditions are as set forth in Exhibit A, with the change, with the addition to proposed condition number 10 of the date, which would be May 9th, 2018. And that concludes my motion.
I will second the motion with the addition of, I can't recall if you put the address into your motion.
I did not.
So the address being 12,000 Vista Del Mar in Playa del Rey. Also, with regard to the equipment, I believe that, as Ms. Hopenstand had explained at the very end of testimony, there is, the second item listed there is just a condition, which now, of course, was moved to the legal section with regard to the variant, the conditions from which the variance will be granted, and also the addition needs to be of boiler number 2 to the equipment. And I don't have that device number, but I believe it's on the exhibit number 5, which is that permit for that boiler, since they have now changed to including the burning of the digester gas in the boiler number 2. And I think the third thing was excess emissions. And I think we don't have a definitive reduction, so we would have to go with the 165 estimated pounds per day of SOx, and that can be adjusted after. Do you accept those changes?
I'll accept those changes.
Okay. Further discussion on the motion? I believe, Senator, you had some discussion.
On condition number 11, the petitioner shall notify the clerk of the board in writing when the final compliance is achieved. What if it's not achieved in that time frame? I mean, things could happen when you start making changes. And if it's not achieved in that time frame, what action should be taken?
The answer is it must be final. They must be in final compliance, or they have no variance relief outside of the 4 days that are granted to them within the time frame of April 30th through May 31st. And so if there is no final compliance, then they would have to seek further.
Shouldn't it be so stated they should request an extension for compliance?
No, that it would just the variance would end.
I can add it further. At that point, if they're not in compliance with the conditions of the variance, if they're not in final compliance, then it's up to the district to take whatever enforcement action it wishes.
The city anticipates to be in full compliance. Otherwise, we would seek emergency relief if necessary. That's also an option. But again, we don't anticipate a problem here based on what you've heard as well today.
Thank you. And back to the deliberation. We did hear testimony from both Ms. Simons and from Mr. Wise with regard to the extra day that was built in as a safety factor. So I think that the city is quite confident, at least based on the testimony, that they will be in final compliance by the end of the 4 days that are being allotted.
As part of the condition, they said day 1 through 4 days. and then 1 day is added as a cushion.
It's within that 4
Even
days.
that 4 days, 1 day was added as a cushion.
That's correct.
It's on them.
Any other discussion on the motion? Seeing none. Ms. Byrd, how do you vote?
Yes.
Dr. Lerner, how do you vote? Yes. Senator, how do you vote? And I vote yes, and Mr. Camarena, as the motion maker, votes
Yes.
yes. Motion passes 5-0. Thank you.
Thank you.
Board members, any other business before we close for the day? Just a reminder to everyone on the board to please check your folders before you leave, if you haven't already, for materials that have been circulated for tomorrow's board meeting. And we are adjourned. Thank you.